before starting with this relation and function, hopefully you have done with set theory, that is it was in class 11, and little bit of relation also was there in class 11, and I hope that you remember all these things. But still, taking into account that this is the first class that I am having with you, I just review the things. Now just let me know what is called a set. Either of you can inform or define it. What is a set? Because we will be studying set, then which will be followed by Cartesian product, followed by we'll come to relation, and finally we'll come to function. And this chapter is one of the most important chapters in maths. This first chapter will be carried forward to each and every chapter that you come across in due course of time in maths. So it is a very, very important chapter, relation and function. And if you don't understand and you go ahead somewhere or the other, you will be definitely facing the problem dealing with such questions where the concept of this entire thing is involved. Now what is a set? How do you define a set?
So set is a well-defined collection of...
Okay, you said it is a well-defined collection, right? Well-defined collection. Now what do you mean by well-defined collection? I write something on the board, you just tell me the answer to this. List of the teams of IPL 2020. Second one, name your favorite team. Third, I can write list the names of teachers in your school. And fourth, I can write name your favorite teacher. If you go through all these four things that I have listed down here on the board, list of the teams of IPL 2020. Now what will be the answer to this particular question? List the names of IPL 2020. My question is, list the names. It means you have to understand the question. List the names of the teams of IPL 2020, which means that you know, everyone knows, and everyone's answer will be unique in the sense that if there are 6 teams in the IPL 2020, then every person will have the same answer. That is, there are 6 teams, and if you are to name the teams, so accordingly you can name it, but no one can have a different answer if all of them know the total number of teams and which are the participating teams of IPL 2020, though it is not done or didn't take place this year. So the list of the teams of IPL 2020 will be the answer which is unique, which will not vary from person to person. Now the second question that is coming here is name your favorite team. Now this particular question, if you ask anyone what is your favorite team in IPL 2020, so this has got different answers. The answers to this question is not unique, which means if you take a collection of the answers of for the second part, that answers will definitely vary from person to person. Someone may be liking KKR, someone may be liking Chennai Super Kings, somewhere like that, but the answer will never be unique. So in this case, this is also a collection. If you take a collection of this, these are all collections. These are all collections. The first collection which we are discussing about is the teams of IPL 2020 is definitely has a unique answer. So this collection, we can call it a set. This collection cannot be called a set. All the collections cannot be defined properly. So those collections which cannot be defined properly are not called sets. The ones, now third one, list the names of the teachers in your school. So you can take the list from the office or somewhere, or you have the list, so you can tell the names of all the teachers of your school. So this is unique. This answer will not vary because all of us know the names of the teachers who are teaching in a particular school. Well, so this collection can be considered to be a set, but at the same time, if I ask you name your favorite teacher, so definitely this answer will not be unique. Everyone or a group of people will be having different set of answers which does not match with the other group. So this particular collection will not be called a set. So this is the concept that you need to understand which particular collection or which collection is considered to be a set. So the definition is okay, well-defined collection, but then well-defined means the answer should be unique and it will make some sense. So this makes a sense, this also makes a sense, but number 2 and number 4 does not make any sense. Okay, so this is, I'm just kidding with you, just a little concept, just revising the facts because everything is related one after the other. So if you have forgotten something, so you can recap it. So next we have, how can you represent the sets? Representation of a set. So how do we represent? There are 2 ways we can represent a set, and that you already know. One is the roster form, and second is the set builder form. Now you know what is the roster form. If I talk of, before that let me ask you something. Notations for some collections already known to us. So this is one of the most important thing, the notices for some collections which you already know. So what does N represent? Can you tell me what does N represent? N represents the set of natural numbers. This is important. I or Z, what is this? This is the set of integers. If we talk of W, this is whole numbers. These things are very important, but many a times I found when the set is given in terms of the symbols, the students get confused what should be the answer. If we talk about Q, can you tell me what is Q? Q represents the set of what? Yes?
Rational numbers.
Rational numbers, right. What is Q plus? Positive rational numbers. What is R? What does R represent? R represents real numbers.
Real numbers.
What does R plus represent? Positive real numbers. What does C represent? Complex numbers. So these are certain collections which we already know, but we have to also know in terms of their symbols. This is very much used in the future. This will be used, so you need to understand and you need to remember. So if the set is given in terms of their symbols, you must take into account, okay, this is the set of natural numbers or whole numbers or integers or whatsoever it is. Now defining about the representation of a set. Now how can we represent a set? And that is done in 2 ways. One is the roster form, one is the set builder form. Now in the roster form, we list the elements directly. List the elements directly. So if I talk about list, write the set in the roster form, which is the collection of the first 10 natural numbers. So you can write set if we represent. So this is notation for the set. A set is always denoted by a capital letter of the alphabet, and the elements are represented by the small alphabets. Okay, so A, and these are written inside a curly bracket. You have the brackets, the round brackets, the square brackets, and the curly brackets. So the elements of a set are always listed inside a curly bracket. So if I write it here, 1, 2, 3, 4, like this, and the last number is 10. So this is the roster form of representing a set. Now the second is the set builder form. Set builder form is actually a generalized way of representing a set. It is a generalized way. Generalized means you have to. Now if you talk about your class, supposing you're talking about your class 12A or 12B. Now suppose the teacher is representing or appointing a monitor for the class. Now what is the job of the monitor? What is the function of the monitor? The monitor has a particular role to play in the classroom. What he does, he describes the activities or the behavior or the characteristics of the classroom. Whenever some information is required by your class teacher, that is being given by the monitor. That means he is keeping a track of the activities taking place in the classroom. So the monitor is the representative for the classroom. Here also in the set builder form, we have to have a representative or a monitor who will describe the characteristics of the elements or the members present in the set. So that is, for example, if you write this same set, if you write the set builder form A, so here we'll write X. So here X is the representative or X is the monitor who will describe the behavior or the characteristics of the elements present in the set. Now X will write after this the two dots, which is a colon, the two dots means colon, or you can write this one a single bar vertical. So this is such that X is less than equals to 10. So for our values are starting from 1 to 10, but if you leave it to here, is the set complete? Is the definition of the set complete? Let me know, yes or no? No, because we have not defined here the set. What is the nature of these numbers? So you need to write X belongs to natural numbers. If you don't write n, that means these numbers can be whole numbers, can be integers, so it will extend towards the left of it. It will take 0, it will take all the negative numbers as well. So you need to define it like this. So X is the monitor of this classroom who tells that we have a collection of all the natural numbers less than or equal to 10. So this particular thing you can also write as X less than 11. This is also correct. Okay, so now we have come to know how the two ways of representing the set. One is the roster form, in which we list the elements directly like this, and in a set builder form, which is a generalized form of representing a set, where the variable X will represent or will act as the monitor for this particular set, who will describe the behavior or the characteristics of this particular set, means what type of elements are listed down in this particular set. Now to move ahead, if we talk about a set A consists of elements WOLF, and set B FOLLOW. Set A has the elements WOLF and B has the elements FOLLOW. So can we say that the two sets are equal or not? The two sets you can see here, W appearing here, W is appearing here as well. O is appearing in the first set A, but O is appearing in second set B twice. L is present in A, L is also present in B, but appearing twice. And last is F. So all the elements which are present in set A are also appearing in set B. What does it mean? That the elements of A and B are present in both the sets, but at the same time we have the number O has been written twice and L has been written twice here. So that means set B is the same as set A. A and B are the same, equal sets. The first thing here to note is that the order of writing the elements is different here. W is written here, W is written at the end in the second set. The order of the elements inside a set does not matter. In whichever order you write, suppose we write A equals to 1, 2, 3 and A equals to 3, 1, 2. it doesn't matter in which order you write. If the same elements are present, that means these two sets are the same set. Okay. Secondly, repetition is allowed. Repetition, even if the digits are or the elements are repeated, it will be counted only once. So whenever the elements are repeated, you don't have to talk about. If you talk about the cardinality of this set, cardinality means the cardinal number, which is the total number of elements present in set A as well in set B. So if you talk about the cardinality, the cardinal number of set A is 4. 1, 2, 3, 4. That is the number of elements present in the set. And what is the cardinality of set B? 1, 2, 3, 4, 5, 6. No, it is not 6. It is 4 only, because the repeating elements will be taken only once. So the cardinal number of both the sets are also the same. Okay, so the repetition is allowed, as well as you can have a different order of writing or listing the elements inside the set, so that will also have no effect. It remains the same, just like A1 to 3 and A3 1 2, both are the same sets. Okay. Now there are different types of sets you must have studied about. You have studied about the different types of sets. One is the empty set, or which we call as the null set. Empty set or null set. What does it mean? A set which has no elements. For example, set A, we write. So here, this is the notation. How do we list the elements in the roster form? A equals to the curly brackets, and inside it we write nothing. We can write the symbol for this null set is 5. Okay. Now, if I take an example, the set of all real numbers, set of all real numbers whose square is -1. So can we have a set of real numbers, or one single real number, or as many real numbers can you take whose square will be giving us -1? So this, we will have no elements, no such real numbers, no such real numbers whose square will give us -1. So in this case, we can say this is a null set in which there are no elements present. So even if you write, suppose if you write this inside this, what can we say about this particular set? If this 5 is included within these curly brackets, then will it be called a null set or not? It will not be called a null set, because something is written inside it. If anything is included inside the curly brackets, it will be considered to be a singleton set, means one element is present inside it. So anything written inside it means it is not a null set or an empty set. So in order to describe or define it as a null set, nothing to be written inside the curly brackets. Then the next one, we can have the second one, the singleton set. Singleton set. What is this singleton set? A set consisting of only one element. Now A equals to, if you write as 5. So this is the set which consists or contains only a single element, or you can say the set of even prime number. The set of even prime number. So the prime number, it must be a prime number, at the same time it is even. So there is only one such number, and that is 2. So this is an even prime number. So this set which consists of only a single element is called a singleton set. Then next one, we talk of cardinality, as just now we have discussed. Cardinal number, or we can say cardinality. We can also call it the order of the set. Order of the set. So whatever I am discussing right now is all the previous things that you have already done in class 11. I'm just reviewing it in this today's class. In the next class, we'll come to our terms with relation and function. So we'll gradually we just move ahead, so that nothing becomes difficult for you to understand in the due course of time. So this is cardinal number or the cardinality as we have mentioned it. It is the total number of elements present in the set. If we 1, 2 and 3, it is represented by n of this set A. This is the notation for the cardinality or the cardinal number, and that gives you the total number of elements present in this set, and that is equals to 3. Okay, so now next one, if we talk about I take the same example now again. I take the same example. Just now we have taken W, O, L, F and set B. The F, O, L, L, O, W. So what is the cardinal number of set A? It has got 1, 2, 3, 4 elements, to write 4. And what is the cardinal number of set B? 1, 2, 3, 4, 5, 6, as I told you, it won't be 6 because repetition is allowed. So but when it is repeated, you will count only once. So 1, 2, 3 and 4. So this is also 4. So the cardinal number of both the sets is 4, and obviously both the sets are also the same set because we can repeat the elements and it will be taken only once. Now the next one is finite set. Finite and infinite set. Finite and infinite set. So what is called a finite set? Finite set means we have got a finite number of elements present in it. That means which are countable. Somewhere or the other it has to come to an end. So if I talk about the set of natural numbers, x is such that x belongs to natural number and x less than equals to 10. So this is a finite set because somewhere or the other there is a finite number of elements and we have got an end point to this. But if we talk about a set where we write x is such that x belongs to natural numbers, or we can continue it, we can write x greater than 5. So this is not finite because there is no end to it. If you start from greater than 5, that means this number starts from 6 and it will continue till infinity, which has got no end point. So the set which has got an end, which are called finite sets, which have got a finite number of elements, and a set where the number of elements are not finite, where there is no end to it, is called an infinite set. Secondly, we have next one is universal set. What is called an universal set? You must be knowing what is an universal set, which is actually we denote it by U or mu like this. So if we talk about a universal set, it means a set containing all the possible elements. A set containing all the possible elements. Now I take an example. If I talk of A equals to 1, 2 and 3. Can you tell me the universal set for this? What will be the universal set for this? So if I take, these are 3 natural numbers, these are also whole numbers, these are also real numbers, these are also integers, we can say, so there are a lot of a number of universal set for this, and this set itself is a universal set of itself. So if you talk about the universal set for this set can be the set of natural numbers, can be the set of integers, can be the set of whole numbers, can be the set of real numbers. So anything we can talk about. You can also have the set 1, 2 and 3. If you talk of set, universal set as 1, 2 and 3. This is also an universal set where all the elements of this set are present in this. So universal set means it consists all the elements of a particular set. So 1 to 3 are also present in this. So this same set can be the universal set for itself. We can also call it 1, 2, 3, 4. This is also an universal set for this particular set A because all the elements of set A are present in the set U where U is 1, 2, 3, 4. So that means what I want to say is that there is not only a unique, you cannot have a unique universal set. You can have many universal sets, but when we deal with questions, then in that case we have to have the possible elements all possible elements in the given context. You have to write in the given context. So in the question you will be provided with a particular universal set. We have a multiple universal sets for a particular set. Just like you took an example of 1 to 3, you can find that there are a number of universal sets like the natural numbers, the whole numbers, the integers, the real numbers, all the numbers, all these were the universal set for these. The set itself was a universal set for itself. So but in a question, when you have to deal with the question, we'll be considering all possible elements in the given context. But that particular question will be consisting of the universal set. So this is the correct definition. Don't write only all possible collections or the elements in a particular set, but you need to join it all possible elements in the given context is the universal set. Okay, now we can talk of the different types of sets. The types of sets. What are the different types of sets? We have already done all these things in class 11. So just a review of the things. The first one, if you talk about equal sets. Now what are equal sets? The first thing condition, the equal sets is that the two sets A and B, if you talk about the two sets A and B, when can you say the two sets A and B are equal? They have exactly the same elements. Exactly the same elements. Maybe you write it in different order, doesn't matter, but it has to be same elements. It is 1, 2, 3 and 4. So you can write it as 4, 1, 2, 3. The order does not matter, as I have already mentioned. So it has got 4 elements. This also got 4 elements. At the same time, that means the cardinal number of A is 4, cardinal number of B is also 4, which means that the number of elements present in both the sets has to be equal. So the first condition is that for the two sets to be equal, the cardinal number must be the same, and once we make sure that the cardinal number are the same, then we have to look into the elements present in the two sets. Now you match, 1 is there, 2 is there, 3 is there and 4 is also there, and no other element, no extra element is present in either of the sets, but all the same elements which are present in set A are also present in set B. Then we can finally say that set A equals to set B. So these are called equal sets. First thing, you have to check the cardinal number. They have to be equal. If they are not equal, so no need to go for checking whether the two sets are equal or not. So the first thing will be the cardinal number, and also the elements must be the same. So now we can talk of equivalent sets. When you talk of equivalent sets, obviously equivalent sets, the definition will be the cardinal number should match. It has nothing to do with the same elements. A set can have elements 1, 2, 3 and 4, and the set B can have elements A, B, C and D. So you check for the cardinal number. This is 4. Check for the cardinal number for set B. This is 4. So if the cardinal numbers are the same for any two sets, then they are equivalent set. Here you don't have to look for whether the elements are equal or not. But if the elements are equal, they are definitely the equivalent sets. So equal sets are always equivalent sets. Equal sets are always equivalent sets, but equivalent sets may or may not be equal sets, because you can very clearly see from here, A is 1, 2, 3, 4, B is A, B, C, D. The elements does not match, but the cardinal number matches, so they are equivalent. If I write another one, 4, 1, 2 and 3, then these two are equivalent as well as equal. But if you talk about these two, they are only equivalent. They have got the same number of elements present in them, but A and C, they have got the cardinal number same. At the same time, the elements are also the same. So they have the same elements, same number of elements. So they are equal as well as equivalent. So equal sets are always equivalent sets. Now we talk about subsets. What are called subsets? Then we have superset as well. subset and superset. So already we know, if you talk about the set A, 1, 2 and 3, and we talk of set B, 1, 2, 3, 4 and 5. So you can find all the elements of set A are present in set B. So if we talk about this, we can write it as the symbol for subset. We write it as like this. This symbol, just stretch C. Normally you write C like this, उसको थोड़ा सा और आगे बढ़ा दो, खींच दो उसको. So this is, and this below it. So this is the symbol for a subset. That means we can get, if A is 1, 2, 3 and B is 1, 2, 3, 4, 5, we can write A is a subset of B. Now, if A is a subset of B, which means these elements of A are present in set B, then B is called, if you call A is a subset of B, then we can say that B is the superset of A. B is the superset of A, when we write just the reverse way. This is the symbol for superset. So if A is a subset of B, then B is called the superset of A. For example, we take another example now. How many? Okay, let me ask you a few questions. So is it, till now, is it clear? Anything, any doubt, any question from your side? I'll be happier to get it. Tell. Any question?
No, sir.
Okay, then I will move ahead and ask. I'll give some question to you. You need to answer it right now and tell me the answer to this. Then we'll move further. My question is, write true or false. The first question I take it as, x is such that x square plus 1 equals to 0. X square plus 1 equals to 0 and x belongs to R. Second, is a null set. Second one is a null set. Third one, 0 belongs to this, and fourth one is a singleton set. So write true and false. Just look into it. You just take these questions, write down T for true, F for false, and take 1 minute time, and then let me know the answer to this question. So what is the answer to the first one? X is such that x square plus 1 equals to 0. Is true or false? Is a null set. True or false?
False.
It is false. Okay. Second one.
False. False.
Third. What is third? True or false?
False.
And fourth one?
So true.
Fourth one is true. Okay. So I have noted down or taken your answers. Now let us discuss these answers. First one, as you have told, it is false. Whether it is false or true, let us find out. If x square plus 1 equals to 0. So x square equals to minus 1. What is this root over minus 1? Is a real number or an imaginary number, complex number? So look at the question. Look at the question we have here. The values of x. X is, as I told you, considered as the monitor of the classroom. You are the monitor of the classroom. You are describing the behavior of it, and x will take values which are real numbers. Okay. So this is coming to, if you put this, solve this, you're getting x equals to root over minus 1. So is it a null set or not? Will there be any elements in this set? Can you list down the elements of this set here in the roster form?
No.
Yes or no? There are no such elements which is a real number whose value is the negative of a square root. Real numbers don't have a negative square root, right? So this is a null set. No such elements exist in a set which is a real number. X is a real number and the value of x is root over minus 1. So root minus 1 is not a real number. So this is a null set. 0 is a null set. You are told it is as false. Now in the beginning when we were discussing about the null set, is this a null set? 0 is a null set, so it is not a null set because one element is already there inside it. So this is false. Now 0 belongs to, what is this symbol? Null set. So does 0 belong to a null set? So 0 belongs to, this symbol belongs to means that this 0 is an element of this set. So in the null set we don't have any elements. So this is false, right? And the last one, this is a singleton set. So as I told you, anything you write inside the curly brackets will be considered as an element. So in this case, this is an element of the set. So this is a singleton set, this is true. So only the first one you have to think on it. So whenever you are getting questions like this, so first all the things are very important and this is one of the most important part. As I told you in the beginning that we discussed about the notations of the various known collections R, N, W, I or Z. That is the importance of this. Here you find this. When you talk about such numbers, such collections, that means you know what is the collection being talked about. So you know what are real numbers. So when you are talking about a real number, so you need to include all such values which are included in this set and are real numbers. So when you solve this, you get root over minus 1, which is not a real number. So obviously no element will be listed inside the set for this particular set. Okay, so hopefully this is clear to you now. So anyway, a little bit of things are still left with the set theory. We will continue from where we have left today because time is over and hopefully did you enjoy the class or not? Just let me know. Or you feel bored about it because you know already all the things.
No sir, yeah, we enjoyed it.
Okay, that's it. So keep enjoying the things. Actually this is the importance of the mathematics. If you enjoy it, it will be very much beneficial for you, that you will be having the level of confidence at a higher level. So that is what is important, that every single thing, because even if you tell me that I know everything about set theory, so I will prove you wrong by giving you questions where you will be confused which will be the right answer and which is not. So you need to keep working on that. That is, research work is very important. So if you are doing right now with integration, so might have whatever sir has discussed with you, sir might have discussed 10 problems, then you have to work on 100 problems to get the concept of that particular chapter. So this is what is called the education. So you need to keep working. If you want to score marks, if you want to score higher marks, if you want to top, then your continuous process should be going on. You cannot relax at any point of time. So that point of time is already over. You have climbed a little mountain, you have climbed a 4-storied building, you have climbed a 5-storied building. It's okay. Now you are climbing the Mount Everest. Mind it. This you keep it in mind. So anyway, all the best. For today we finish it here. So next class when we meet again, we'll continue from where we stopped here. So till then, bye bye. Have a nice day. Thank you very much.